Hello, everyone. I'm Surag Patel, CEO and co-founder of Pixee. Today's presentation is going to be a bit like what I like to call PowerPoint karaoke. We were planning to do a live demo because of some technical difficulties. You're going to see some screenshots in a little while, so I'll get to explain them in that way. Make it work. When we started Pixee a couple years ago, we started with a very simple belief. Too much is expected of software developers, right? We expect them to deliver features yesterday. We want them to be perfectly performant. We want them to have every capability we expected them to have. We want them to be secure and fast and cheap and all these other things. There's a lot of data and reports from Microsoft and many other folks that kind of continue to go back and say developers end up spending about a day a week, 1 out of every 5 days on security-related work. These are not security engineers. These are normal software developers. And we believe that was just too much. When you think about it from a code and security and vulnerability perspective, there's plenty of tools that have been built over the last 2 decades that help you find flaws in the code software developers are writing. Now, today, it'll find flaws not just in the human written code, but now the AI written code as well, right? But to fix all of those is actually extremely time consuming. It's a very manual process. Even in 2025, it's done manually. There's a ton of vulnerabilities, there's a ton of vulnerabilities that developers will create, intentionally or unintentionally. Now AI will create, generally unintentionally. To fix it requires a very specific expertise of security, the context of the code and how it flows. And that pain is what causes this 1 out of 5 days of time spent by developers fixing security things all day long. On the back of that, the idea is like we built Pixee. So we spent a couple years building Pixee. Think of Pixee as your automated product security engineer. It is absolutely uses AI in different ways, but for many things it does not need to use AI. It will not use AI. I'll show you a couple examples in a little bit, but built for the enterprises. And what do we mean by that? Enterprises have very specific requirements on the quality of the code that goes through their systems and the quality of the code that ends up in the software that they deliver. To do that requires very specific knowledge on their code, not general code, but their code, and the kinds of security things that might impact them. And so we've designed in that way. We've also designed in ways that in today's world, when AI can be used to do things like evaluate your source code, actually a very sensitive topic if you think about it. It's their source code used in an AI in the cloud is probably a no-go for almost any company in this room. And so we've designed this in a way where our customers can fully self-deploy their entire stack of Pixee in their own environment. They don't have to worry about their source code leaving. They don't have to worry about using an AI that gets trained on their source code and their IP. They can use it in a way that they feel confident and secure to use it at scale. A little bit about us and the team. I founded this company with a gentleman named Arshan Dabir-Siagi, who was the co-founder of the last company I was at. We collectively, between us, have spent 45 years in application security, which is quite unique. We previously built a company I've personally built throughout my career or been a part of several unicorns through that journey, and I was fortunate to be part of those journeys, some in digital media, and then recently some in cybersecurity. Most recently a company called Contrast Security that was in the application security testing space. And that's where we got to see the forefront of this whole, for those of you who have been in cybersecurity for some time, the last 5 years of topics around DevSecOps as a category and as a theme. Today, you don't hear it as much because candidly, if you ask people, they'll tell you it was a failure in most cases. It has added a lot of toil and a lot of great presentations, but in terms of efficiency and outcomes and goals and objectives, most folks will tell you it hasn't quite lived up to what they expected it to. And that's the whole reason why we kind of focus on Pixee and the idea of focusing on the fixing, not the finding of a vulnerability. So what do we do? So with AI, Pixee uses AI in numerous ways. I'll show you some overly complicated slides in just a moment. Well, we do 2 core things that AI helps us with. The first is triage findings. So as your developers are running code scanners, any code scanner, there's 50 of them out there that they can use all the way from open source to free to commercial ones. They will spit out thousands, tens of thousands, hundreds of thousands, even millions of vulnerabilities found all the time. Your first thing before you think about fixing any of those is you have to triage them. And that triage requires expertise about specific software security knowledge. And so we do that automatically. I'll show you an example of that. And then, the second piece of it is in fix. So we then become the author. We make a code change back into GitHub or GitLab or Azure DevOps or Bitbucket. We rewrite the code to fix the vulnerability that was introduced and found by the scanners you have. And then a developer, the human, is just a reviewer. So they get to say, look at it, take 2 or 3 minutes, say it looks good, hit merge, and they've just saved the whole company collectively for each vulnerability probably somewhere between 5 and 25 hours of time. And that happens tens of thousands of times for probably every company in this room. Why does this all matter? At the end of the day, it comes back to saving time for developers. How do we buy back time for your technical staff that are very valuable? And how do we buy back time and allow your very understaffed security teams to be able to scale to support your hundreds or thousands of developers with a very small team of 1 or 2 people? And what we see is 3/4 of the time that security teams are spending triaging, they're getting back. They don't have to do that because we the AI collectively, does the heavy lifting for them. And then developers are spending less than 10% of the time they were spending before fixing things. And that's because we are the author, they get to be the reviewer, and it's a very quick process from there on out. And this last step is a piece that kind of really gets us excited about what can happen when you use AI in a thoughtful, cohesive way, where you're not just spitting out garbage, right? We're not just spitting out code changes, hoping that developers will accept them and that they work and that they're good. This is a metric we strive for. So when we make a code change back to your code base, they get accepted by developers more than 3/4 of the time, without a single edit by the developer, by the human. In most other cases, you think about like some of the best-in-class tools like GitHub Copilot, something I was talking about, or Claude Code, many of those changes are accepted at sub 20 or 30%. They'll make some changes, developers need to make another edit, go back and revisit. Finally, you'll get a change that they'll accept. And so because of our very specialized focus, this is a very critical metric for us as we measure success of what we do and how we do it. I won't go through all the details here, but the summary of this slide is when we talk about making a fix, it's not all AI. We don't just hand the wheels to AI and let AI go figure out what to do. There's various elements of what need to happen. You need to get context of the code. You then need to make a code diff, or actually rewrite the code. And then you need to validate if that code diff is good. All of those 3 distinct components may or may not use AI. So we have this is only 4, there's actually another 4 different ways that we make fixes, and it will vary from class to class, to language, to tool. And there's pros and cons in each and every one. But what you have to realize is the way you get to those high levels of merge rates and acceptance rates is by having this level of complexity that we obfuscate for our users so that they can get the outcomes they want. The same thing goes to the triage. This is one agentic model we use to triage and validate one type of vulnerability. Cross-site scripting is a type of vulnerability. In this specific model, there are 8 different AI agents doing 8 different things because that's the complexity it takes to get the level of quality enterprises expect. And so you have agents that can be highly specialized, developing very specific activity that they can do independently and well. And when you mash that all together, you get the types of outcomes that they want. So I'll just show you a few screenshots. I'll skip the animations here, but there's a flow that this all works in. It's kind of meant to be in the developer flow. This is an example of us, Pixee, our technology, making a code change back to a developer. So this is exactly like a code change would look like from a human. In this case, it was done by our product. We made a code diff, as you can kind of see it on this slide. The red are the lines we deleted, the greens are the slides we added, and this fixes a SQL injection vulnerability. This is a critical vulnerability. This kind of vulnerability within most companies is probably a collective effort between development and security teams, 20 to 50 hours of time to do this one reasonably simple task. But we automate that. The context of fixing a false positive is first, I mentioned you have to evaluate context. There's very few people in this world who know application security and are trained on it. As a matter of fact, depending on which report you read, the ratio within large companies is generally 400 to 500 developers to every 1 AppSec person who knows how to do what I'm talking about here. And this provides back examples on, you can see a full write-up on saying, like, here's what your code did. It did this, and then it did this, and then it did this. And what you won't be able to read, but what this is summary saying is your scanner told you get a insecure hashing algorithm in this case. You're using a password in the text. And what our AI was able to do is say, like, no, as a matter of fact, it's a false positive, and here's exactly why. Because what you thought was a password is actually an email address that's used in a test case, and here's all the evidence behind it, and therefore you can just close that thing out and save time for all the people who would have wasted time trying to figure out what this is and if they should fix it. With that, I'll leave it at that. Our whole objective is how do we help enterprises mass remediate these vulnerabilities that they have so that they can buy back that time. Excellent, thank you.